This is a short presentation on NeuroTracker, which is a new training technology for enhancing multiple object tracking in team sports, and this is done through neurophysical training. We will outline the company, introduce the products, and go through some of the applied training principles and direct benefits of this new approach. CogniSens is a company that specializes in applying neurobiological science and technology to the field of sports. The science behind NeuroTracker is driven by world-leading neurophysicist Dr. Jocelyn Faber, who is the director of the Visual Psychophysics and Perception Laboratory based at the University of Montreal. NeuroTracker has emerged from combining the fields of neurophysics, VR tech, and sports science. As such, this represents a truly innovative yet scientifically grounded approach to training athletes. The first two sports teams to have full access to NeuroTracker training are Manchester United Football Club and Stade Toulousain, who recently won the Rugby European Cup. As the world's largest and most popular sports team, Manchester United are continuously assessing a huge range of new training technologies. After 8 months of trials, they confirmed that NeuroTracker is one of the most impressive they have ever seen. Although we only launched NeuroTracker at the Football World Cup in South Africa this past July, we have already received interest in multiple sports. We have NeuroTracker systems set up in Everton EPL, the Pittsburgh Penguins, the Vancouver Canucks, and the Ottawa Senators, and are in discussions with many more teams in professional soccer, hockey, rugby, and American football. NeuroTracker itself is relatively simple, with most athletes fully engaged in the training within a minute's instruction. Essentially, 4 spheres are targeted for tracking and then blend with another 4. These then move randomly through true 3D space, deflecting and crossing over each other. With correct identifications, the speed and difficulty increases to each athlete's threshold over 15 trials. Although simple to attempt, this is a complex cognitive process that activates significant mental resources. Training allows athletes to both expand the amount of movement information they can absorb in the field and process the information more efficiently. This technique is completely safe and can only add to an athlete's performance abilities. This skill is highly relevant to team sports, which constantly overwhelm athletes with scenes of complex and dynamic motion. In team sports, cognitive skills are central to a whole range of performance demands. This has been well founded in sports science literature, with the contrast between elite and sub-elite athletes being minimal physiologically, but large mentally. Simultaneous demands across many mental skills easily overwhelm players, causing cognitive bottlenecks and limiting performance. 3D multiple object tracking is a core perceptual skill and is highly trainable. Increased proficiency in this area can free up processing resources for other mental skills. By far the largest advantage of NeuroTracker is the pronounced effects of training. In terms of actual time spent tracking spheres, 1 hour produces an average improvement of over 50%. This has been confirmed scientifically both with the general population and with elite athletes in the field. Neuroplasticity is the reason these gains are attainable, as the brain is remarkably good at rewiring itself anatomically to adapt to intensive functional tasks. The phenomenon of distributed learning means that small amounts of training spread out over time increases these effects due to the role of mental rest and sleep. Each NeuroTracker session lasts just 6 minutes. A true sports science methodology can be applied perfectly with NeuroTracker training. Core perceptual skills are targeted for training in a way that is similar to doing squats to build up leg power for generic gains in sprinting, decelerating, and jumping. Maximal stimulation is achieved by an intelligent staircase procedure that pushes an athlete above and below their NeuroTracker threshold. The 6-minute sessions are highly practical and can even be integrated into circuit training routines with physical exercises. NeuroTracker conditioning takes place in a CogniSens cave, in which up to 5 athletes can train at the same time. This light-controlled structure can be set up in a gym, with only a single power cable required outside of the cube. An 8-foot wide true 3D environment is created with the latest technology in ultra-short range projection and wireless shutter glasses. NeuroTracker is provided through a spectrum of 9 different sessions. Standard programs use scientific measurement procedures useful for the assessment of cognitive agility and improvement rates. Advanced programs layer additional perceptual tasks onto standard training. These relate generically to in-field tactical skills. Team programs bring psychological dimensions into NeuroTracker testing, conditioning athletes cooperatively or under pressure competitively. Large amounts of NeuroTracker data is generated from the 15 mini-trials comprised within each session. Scores and progress rates are displayed automatically in graph form at the end of each test, and all the details of results go straight into a database. Any or all data is available instantly to coaches through simple yet powerful motion charts. These reveal deep trends quickly and intuitively in a range of displays. The results of NeuroTracker tests represent a vanguard for cognitive assessment of athletes, as the data provides a direct indicator of perceptual performance capabilities. This new form of intelligence on athletes can complement other assessments for a fuller understanding of each player's overall skill set. As an emerging sports technology, NeuroTracker is particularly valuable for recruitment testing, as it provides an untapped area of performance assessment. A range of other benefits exist outside of the principal gains of performance enhancement. NeuroTracker also provides a medical role for supporting assessment of concussions. Typically, NeuroTracker ability will be drastically reduced under the effect of MTBIs, or mild traumatic brain injuries, which compromise critical high-level visual resources. Such tests present quantitative and unbiased evidence for when a player is back in game shape. Additionally, NeuroTracker also trains the athlete to lessen the possibility of concussive collisions. The mental resources required to maintain awareness of possible threats are substantial, and can be overwhelming when paired with a high degree of concentration on other tasks. NHL studies throughout 2006 to 2010 have recently shown that 44% of concussions occur within 0.3 seconds of releasing the puck, strongly suggesting a critical loss of peripheral awareness due to temporary attentional overload. Increasing a player's ability to avoid collisions is his first line of defense, and for this, physical agility needs to be guided by perceptual awareness. This is achieved through improving the player's ability to absorb more visual information and process a wider field of perception. Gains in perceptual dexterity can then be applied in-field for automaticity conditioning, so the player becomes instinctively more aware of threats. NeuroTracker can also be performed on an exercise bike in the cave, where results correlated with biofeedback data can then reveal the extent of physiological fatigue on each athlete's concentration, and may well provide a method for conditioning resistance. Finally, injured athletes can get a great deal out of NeuroTracker, as the training is non-physical and can be carried out intensively. It allows a player to return to competition with significantly increased abilities, boosting confidence at a critical period. Athletes injured long-term can be identified for cognitive regression brought about through a sustained lack of game stimulation. In these cases, NeuroTracker conditioning can then be applied to accelerate cognitive rejuvenation.